Good morning, good afternoon, and good evening, everyone, depending on where you are. Thank you for joining this session on Mastering Data Management in Microsoft Fabric, the time travel and the table optimization aspects within it. Before we start, a little bit about myself. I'm Nandan Hegde. I work as a data architect at Accenture, and I'm also the founder of a tech education aspect called Data Sharks. I am a 3 times Microsoft Data Platform MVP, a 2 times C# Corner MVP, a Microsoft Fabric super user, and a Microsoft Data Community Champion. You all can reach out to me via my LinkedIn or my Twitter profile or via my blog profile as well. Now enough about myself, and let's move on to the crux of the session. Now, apologies in advance to those who are already familiar with what Microsoft Fabric is, but to those who are new to this ecosystem, I'll explain in one liner what Microsoft Fabric is. So Microsoft Fabric is basically a software as a service tool created by Microsoft that provides an end-to-end analytical and data platform that is designed for enterprises that require a unified solution. So one can consider Microsoft Fabric as a one-stop shop for everything, right from data movement to data transformations, data storing, data science, real-time streaming aspects, analytics and alerts. And everything is hosted on a logical concept of something called as one lake, which is like your storage layer aspect. Now, before we deep dive into the concept of Microsoft Fabric optimization, first we need to understand the underlying storage concept of it. So before we proceed to the crux, that is optimization and other aspects, let's understand the basic of the different file types in the data world. In the data ecosystem, files are classified into two major categories. One is a row-based file format, another is a column-based file format. Now let's deep dive into each of these file format. Now in row-based file format, and this is the traditional file format. That is, the data is stored as sequence of rows, something like this, wherein these are the columns or the attributes of an entity. So this is my entity called sales table or sales file. Within that, I have different columns or what we call as attributes like product, customer, country, date, and sales amount. Now the data is stored as sequence of rows. So this is one row. This is one transaction that I had wherein John Doe from USA country bought a ball product with the sales amount 100 on 1st of January 2023. So every transaction or the data is stored as a sequence of rows. Now imagine that within this data, now here I have stated for OLAP aspect, OLAP stands for online analytical processing. Basically any data system can be classified into two categories, OLTP, transactional processing, and analytical processing. Now in analytical processing, as the name suggests, we want the data to be for analytical purposes. And what are the analytical aspects like? How many users from the USA bought a t-shirt? Or what is the total amount spent by customer Maria Adams? So now let's take a look with respect to this scenario. As to, I need to do an analysis with respect to what is the total amount spent by customer Maria Adams. So in this case, first of all, I am interested with respect to two attributes. One is the sales amount and another is with respect to the customer. But in case of row-based file format, first I have to filter out where customer is Maria Adams. So in that case, what I have to do is I have to parse across each and every, I have to scan across each and every row and every column. So in this case, in order for me to answer on this aspect, I have to scan the entirety of first row and all the columns within the first row, then move to the second row, scan all columns within second row, and so on so forth. So in this case, I must scan each and every row from the beginning to the very end. But essentially, we just need the information from two columns, that is sales amount and the customer column. But the engine has to scan across all the 5 columns as well as all the rows. Now, this becomes a concerning aspect because there is unnecessary efforts spent across scanning on additional columns which are not intended for the use aspect. So for that, there is another type of file format called column-based file format. If you see the difference, correct, wherein ball, t-shirt, socks, correct. The difference between row-based and file is they are closely knit together in case of row-based file format. But here, each column is physically separated from another column from the other columns. So now the engine can now can scan only those columns that are needed by the query. So in case of the query, that is what is the total amount spent by customer Maria Adams, I just have to scan the customer column and the sales amounts column, thereby allowing me to skip the scanning of the unnecessary columns like product, country, and date, and thereby improving the overall performance of the analytical queries. But the question still begs here, that is, even though I was able to reduce the number of scanning of the unnecessary columns, but in this scenario, I still have to scan each and every row, meaning now I'll scan the first row, but in that I'll scan customer and sales amount column. Then I'll go to the second row, John Doe and 200, and then I'll filter out on these two rows. So in case of column-based file format, it still has to scan across every row, but it can skip the scanning of the unnecessary columns, that is, in this scenario, product, country, and date. So now let's understand the bifurcation between the row-based and the column-based file formats. So in case of row-based file formats, the storage is in the form of rows, whereas in case of column-based file formats, the columns are bound together. Now the use cases for analytical aspects for fast column scans, it is the column-based file formats that is much more preferable. But in case of transactional processing or fast row access, it is the row-based file formats that are needed. So in case of row access, this is quicker. In case of column access, this is quicker. Now some of the examples of row-based file formats are traditional CSV or Excel files. In case of column-based file formats, we have Parquet and ORC. And the crux of the file that we would focus on in this session would be the Parquet file format. And we'll understand why we are focusing on the Parquet file format. So Parquet file format is basically a columnar file format that stores the data in row groups. What do I mean by that? So there is another author, Nicola, who has created this presentation aspect, and in his terminology, one can consider that Parquet is like a columnar based file format with metadata aspect, meaning if you see the columns are separated, but the rows are combined in the form of groups. row groups. So there is some aggregation at the row level as well. So now, in case if I have to answer the question with respect to how much transactional amount did Maria Adams do. So in this case, in case of Parquet file format, since it's a columnar file format, I'll automatically skip the scanning of product, country and the date column. But the advantage of Parquet file format over the traditional column file format is, in this case, I can skip row 1 and row 2, that is row group 1, because in row group 1, there is no Maria Adams present. So in that case, what I'll have to do is I'll scan row group 2, meaning the rows present within the row group 2 and the rows that are present within the row group 3, thereby improving the scanning aspect across the whole. So one can consider that in case of the row store file format, the engine had to scan across all 5 columns and all the 6 rows. In case of the traditional column based file format, the engine had to scan only 2 columns but still had to scan all 6 rows. But in case of Parquet file format, the engine only had to scan 2 columns and 4 rows. But now the question begs is, how does the Parquet file format know which row group to skip and scan? It is because the Parquet file contains metadata, meaning every Parquet file contains data about the data, like information such as minimum and maximum values in a specific column within that certain row group. And hence, in this case, within the customer column, in the row group 1, the distinct value is only John Doe. So basically, the Parquet file first scans the metadata, then depending upon the metadata, decides whether to scan or skip the corresponding row group. This is about the concept of Parquet files. Now, within Microsoft Fabric ecosystem, there are, as of today, in general, there are 4 storage layers that are available. One is the Fabric Lakehouse. Now, the Fabric Lakehouse can be considered as the data lake equivalent in the in the data ecosystem. Warehouse can be considered as the data warehouse in the data ecosystem. SQL database is like your transactional database equivalent, and KQL database is basically for your streaming aspect. Now in Microsoft Fabric, whenever you load any data within Lakehouse or Warehouse, the underlying data is being preserved in the form of Delta Parquet file format. Now, what do I mean by Delta Parquet file format? Up till now, I heard the concept of Parquet file format, correct? Delta Parquet file format can be considered as Parquet file format on steroids, the terminology used by Nicola. What do I mean by that? Now, those who are familiar with the concept of SQL Server, wherein you have the main database file and the log database file, that is MDF and LDF file. One can consider Delta Parquet file similar to that. Let's understand the equivalency between those two. Now, in the SQL Server main database file, the MDF file actually contained the data, whereas the LDF file, that is the log database file, contained the transactional changes on that corresponding data. Meaning, in case if I inserted something, if I updated, those transactional aspects were being preserved within the log database file. Similar is the concept with respect to the Delta Parquet format. The Parquet file contains the data, whereas the Delta contains the log file with respect to the transactional aspect. Now, the lakehouse and the warehouse in the Fabric ecosystem preserve the data in the underlying format of Delta Parquet format. Hence, in this session, we would be focusing on the lakehouse and the warehouse concept. SQL database and KQL database have the data in the proprietary storage format. What do I mean by proprietary storage format? We do not know. The Microsoft has its own way of preserving it, which is not known to the end users. Now, let's first take a look with respect to what I meant with respect to the lakehouse preserves the data in the underlying Delta Parquet file itself. So within my Fabric workspace, I have a component called Fabric lakehouse called lake. So let me go to that lakehouse. Now within this lakehouse, within the tables, I have a table called test wherein I am able to see this data 54312. Now in case if I click on this ellipsis and if I click on view files, it takes me to the underlying structure on how the data is actually preserved within the Fabric ecosystem. You can see that I have Parquet files. Parquet files are the one that actually preserve your data. So in case if I go to the table view, I can see that this table contains 5 different rows. Now in case if I go to the file view, I can see that there are 5 different Parquet files as of now. Let me go to one of the Parquet file. I can see that it contains one of the row data 4 and hello world 4. So one can state that the Parquet file contains the underlying data, whereas the delta folder contains the transactional aspect pertaining to that. So in case if you see the multiple JSON files, these are the transactions that have transpired within this table. So if I click on this data, I can see that a value was appended or a write operation happened wherein a value got inserted or written within the corresponding lakehouse table. Here I can see that in the first transaction file 0000, I can see that the table got created. So this is what we mean by Delta Parquet file, and Fabric Lakehouse preserves the data and in the underlying Delta Parquet file format itself. So now let me go ahead and delete this table. Now let me open a notebook. Notebook is basically a way for you to execute or do your transformations at the Fabric ecosystem. So within that notebook, I have mounted my corresponding lakehouse. So now let me go ahead and create a table called TT within my corresponding lakehouse. So for that, %% is a magic command that states that rather than using the traditional PySpark language, use the Spark SQL language. And I can execute queries within my notebook via normal SQL queries like create table. Now, since I'm executing this query for the first time, for the session to become active, it takes a couple of seconds. By the time this is getting executed, in this aspect, we would be discussing the concept of time travel. As the name suggests, time travel. So time travel in Microsoft Fabric allows one to query and restore data from a previous point in time using the concept of Delta Lake technology. Now this terminology is very critical and you will understand it is the reason that we are preserving the data in the form of Delta Parquet wherein we do have the log transaction steps. We are able to move across different periods within that data. So time travel basically lets you query previous versions of a delta table at any point using either a timestamp or a version number, and we'll take a look as to what that means. So in layman terminology, if I have to state what time travel is, imagine that I have a table that is getting populated daily on basis of certain jobs. Today, if I do a select query from that table, I'll be able to see the state of that table as of today. But imagine I want to check what was the data as of 2 days back in that table. That is what time travel is. So let's understand the benefit or advantage of that time travel functionality that Microsoft provides. So it's like having a rewind button for your data, correct? Imagine that I accidentally deleted the rows. Via time travel, I can roll back it to the previous state wherein I did had that data. Or imagine I want to do the historical analysis as to how I made, as to when I did the corresponding changes. I can go and query the old versions of the data. So in layman terminology, if I have to state, I can undo the mistakes that I had done with respect to delete, update, overwrite issues. I can use it for debugging purposes like process historical data snapshots, or I can do for audit and compliance in case if I have to do data traceability requirements, historical data traceability requirements. So now let's take the practical aspect with respect to the same. So now if you see my corresponding query got executed, and in case if I go to my lakehouse under tables, if I refresh the corresponding table section, I can see that the time travel table, the TT table got created. Now, in case if I go to the view file sections, I can see that there is no Parquet file, there is only delta log file. The reason for that is I have just created the table. The table does not host any data as of now. Hence, I can only see the delta folder that contains a transaction called create table with this corresponding structure. Now, let me go ahead and insert couple of rows within that corresponding table. So now I'm inserting 2 rows within the corresponding table that I created. So by the time this got executed, now let me go back and check the lakehouse. Now in case if I refresh this, I can see that 2 new Parquet files have been added, and within the delta folder I can see that 2 JSON files have been added. Now let's take a look with respect to what that is. So corresponding to this Parquet file, I can see it has loaded the first, it contains the first row, and the second Parquet file contains this second row. And in case if I go within my log file, I can see that a write operation was created, and for that corresponding write operation, a corresponding Parquet file got created, which is this, that is 4D18A5. 4D18A5, meaning in this transactional aspect, first the corresponding Parquet that got created was this Parquet file. So there is a tight bounding between the transaction log file and the data file. Whereas the second JSON states that it's this path that is active, meaning corresponding to this transaction, this corresponding Parquet file got created. And for every transactional aspect, there is a corresponding timestamp that is being preserved within the log files. So now let me go ahead and execute this query called describe history time travel. So within the lakehouse, there is a query wherein you can execute describe history time travel that would provide you all the history that have been executed within this corresponding table. So I can see that there are two versions that has happened, three versions. Version 0 states that a create table operation was executed. Version 1 states that write operation was done. Version 2 states a write operation was done. So now let me execute. Let me check the overall status of the table as of now. So in case if I execute this query, this should provide me two rows, because as of now there are two rows that are present, 1, 2 and the corresponding hello world title. But imagine if I want to check the status of this table at this version. So there is a keyword wherein you can time travel back to this state of the table leveraging the keyword called version as of. So now I can check the status of this TT table at the state of version 1. So for that I need to execute this query called select all from time travel version as of. I want as of this version. So when I execute this would provide me with only one row, because as of version 1 there was only one row that was present within the lakehouse table. But rather than version, you can also leverage the concept of timestamp. So as of this timestamp, I want to check what my corresponding state of the table was. So rather than using the version keyword, I can do it based on the timestamp, wherein select all from that table timestamp as of that corresponding timestamp at which I want to see the data. So as of this particular time up till second, there was only one row present. But post that, there were two rows that were present across the lakehouse. So this is the concept of time travel within the Fabric lakehouse. Now the benefit of the time travel is, as we said, in case if I want to analyze on some historical aspect, or I want to restore the table as of that corresponding time or version, I can restore it. So in this case, I can create or replace a table called restored underscore table within the lakehouse that would contain the data as of the version 1. So in this case, you can create your backup table, snapshot tables pertaining to based on the concept of time travel. So now the table got created, and now in case if I execute this, I'll be able to see the data is present. Now, even though I created the time travel aspect, what it does is, see, in case of time travel, if I'm creating a new table based on that time travel functionality, the original table contains the Parquet file, correct? So when you create the replica of that table, the Parquet file or the data is not duplicated. It would still refer to the Parquet file that is present in the original table via which you are creating that corresponding clone or replica. In that way, you are preserving this. Microsoft is preserving the storage cost that gets associated with it. So this is with respect to time travel in the lakehouse. But as I stated that Microsoft Fabric Warehouse also preserves the data, underlying data, in the form of Delta Parquet itself. So for that, since time travel is hosted on the concept of Delta Lake technology, since Fabric Warehouse also preserves the underlying data in the form of Delta Parquet itself, one can leverage the concept of time travel in the Fabric Warehouse as well. So now I have hosted a warehouse within my corresponding notebook. This is the T-SQL version of the notebook. So now I'll quickly create a table called time travel. It states that there is already a table called time travel within my warehouse. So hence let me go ahead and drop it. So my table got dropped off. Now let me go ahead and create a table. So this created the corresponding table in my fabric warehouse. Now let me insert couple of records within this corresponding table. The records got inserted. Now let me capture the current time value as to when there are only 2 rows that are present within my fabric warehouse. Now let me insert 2 rows again. Now if I want to check the overall data in my time travel table as of now, if I execute this query, this would show me there are 4 rows that are present because I inserted two rows twice. But now if I want to check the state of my table prior to this execution, meaning at this particular time, there is an option wherein, unlike Fabric Lakehouse, wherein you could do based on the time or version, in Fabric Warehouse, there is no concept of version. You can only do time travel on the basis of timestamp. And this is the keyword wherein select all from the table. That's the normal aspect option for timestamp as of the corresponding timestamp that you want the data for. So now we can see that prior this time was prior to the time when this 2 additional rows got inserted, and I was able to travel back in time to check the status of that table, and I'm able to see 2 rows. So this is the concept of time travel. Now let's get about optimization and maintenance within the Fabric ecosystem. Now we saw that the underlying data is preserved in the form of delta parquet files. So now optimizing your delta tables in your lakehouse, basically what it does is it ensures faster queries, better performance and efficient storage usage. Now there are different methods, maintenance methods, in order to ensure that you have optimized your delta tables. One is via the optimize command. Now what optimize command does is, we saw, correct, there were multiple parquet files. Even for one row, there was one parquet file. Now every parquet file contains some metadata. So every time whenever I have to scan the parquet file, I have to first scan the metadata and then go across the row. So imagine that if there are only one row per file, first it has to scan the metadata and then scan the row. In turn, we are degrading the performance. So rather than having small parquet file, it is better to have a large parquet file with multiple rows and one metadata row. In that way, it would benefit the concept of metadata for us to scan across the necessary rows via row groups. Hence, the optimize command basically consolidates multiple small parquet files into large file, which in turn improves the read performance. Because rather than scanning 5 different parquet files, I'll scan one parquet file with one metadata, meaning I have to scan the metadata only once rather than 5 different times. Then there is something called as V order and Z order. Those who are familiar with indexing, one can consider V order, Z order somewhat similar to indexing. It is with respect to how we are preserving the data within that corresponding parquet file. So basically V order applies optimized sorting, encoding to enable fast read operation across all the Fabric engines. Whereas Z order is used to improve the query performance by physically organizing the data in the way that reduces the amount of data scanned. So let's understand Z order in detail. So let's take a scenario that I frequently execute queries like select from sales date where, meaning I do filtering aspect. So Z order is for fast filtering. Without Z order, Fabric might have to scan the entire table, even if only 1% of the data is irrelevant, because there might be only specific rows with this specific data. When I do the Z order sorts the table by the corresponding columns on which I'm filtering or on which I'm doing the Z order, like sales date and store location. So in case if I execute this command, optimize sales data table, Z order by sales date store location, Microsoft Fabric would organize the related rows together. So in that way, it can skip large chunks of data during queries, making them much faster. Whereas V order is for smaller and smarter files, wherein the delta files currently store column data in inefficient layout. Whereas V order would optimize the column layout inside each of the delta parquet file. So basically it reorders how the data is written to the disk, reducing the read time and the storage cost. So the analog which one can consider is before V order, clothes are thrown randomly into my suitcase. But once I execute V order, I am properly folding and arranging them efficiently within my suitcase. So in a pictorial representation, one can consider Z order as column level layout and ordering in proper aspect, whereas V order is proper row level clustering. Now, these are the reference. Enough theoretical aspect. Let's take a practical look with respect to the optimization. So now, under optimization, I'll be executing this via the notebook concept itself. Now, by default, whenever Microsoft Fabric writes the data into the lakehouse, it's write enabled. So I need to disable of this property. Now, this property is specific for this specific session itself. Meaning for this specific session itself, I am disabling the optimize write property. But in case if I parallelly execute another notebook, it would be in the enable state itself. Now let's check whether the corresponding property has been disabled or not. So it's disabled. Now let me go ahead and create a table called test. Here I have used the keyword called using delta, but in the earlier during time travel I had commented it out. So irrespective of whether you use the using delta or not, underlying in the lakehouse the data is being preserved in the form of delta parquet only. Now let me execute some insert queries within that table. Now the data is getting inserted within that table. Now in case if I go into my lakehouse, if I refresh the table section, I can see that a test table has been created. But the aspect with respect to that is corresponding to those 5 rows, 5 different parquet files has been created, and this in turn would ensure that every row is present in every meaning one row is present in one file, which is not an optimized way of doing it. So within the portal aspect itself, if you click on the 3 ellipses, there is a maintenance aspect wherein you can click on run optimize command and apply V order. What it does is now the optimize command is trying to aggregate, merge these 5 files into one larger file for better read purposes. So one can execute the optimize command via the UI interface or via notebook as well, wherein I can execute the optimize, the lakehouse name and the corresponding table name. Earlier, by default, when you executed this, the data used to be ordered by V order by default. But in last 1 month, Microsoft has disabled the default aspect and one has to explicitly mention V order in case one expects it to be done by V order. So now optimization does take time, correct? Because it is trying to merge those files into one single file. So let's wait for a couple of minutes for it to get executed. Now I can also execute show TBL properties. That is, it provides me the different versions within the corresponding table that has been executed. So optimization is still taking place. So by the time the optimization is taking place, let's understand the final concept with respect to something called as vacuum. Now, as I said, the optimize command merges multiple small files or consolidates multiple small Parquet files into a larger file. Now, the larger file would still contain the same data. Correct? It would contain all the file rows in a single file. So there are other 5 files that would still be present and that will take a look once the optimize command has been executed. But in order, so there is a duplicate amount of data that is present within my Fabric Lakehouse, which in turn increases the storage cost as well. So imagine that if I want to remove such obsolete data files that are no longer referenced by the Delta table in the live version, I can execute the vacuum command. This helps in reclaiming the storage space and maintaining the overall table health. So I can see that the vacuum command has been executed. Now let me refresh my table. I can see that in case if I order it by modified date, I can see that 1, 2, 3, 4, 5, a new Parquet file got has created. And if I click on this, I can see that this Parquet file contains the accumulation of all the data that is present across all other Parquet files. And remember this Parquet file name. It is 73A5A. Under the log folder, also if I click on the latest aspect, on the 6th JSON, I can see that an optimize command was executed and V order was executed. Now, if you see here, with this execution, what it did is it added this as the latest file path, wherein the minimum value is 1 and the maximum value is this, the metadata that we are talking about. Correct? And it removed all other paths. Removed meaning these files are no longer needed because all these files has now been merged or merged into the latest file, which is this Parquet file, that is 73A5A. So now whenever I'll execute select star from this table, Microsoft Fabric would come to this latest JSON file, transactional file, and would consider that this Parquet file as the active file path, which we saw earlier, and it would come and scan only this corresponding Parquet, sorry, not this one, 35A, and scan across this data, thereby ignoring the other files. This is what we call as optimization. Now, in case if I want to optimize and do a Z order on top of V order, I can execute this command and on which column do I want to do a Z order, I can mention this. So this was with respect to the concept of optimization. Now we saw that these files are no longer needed, correct? But imagine that if I want to time travel back, see, every transaction happened at a specific point of time. Now imagine that if I delete all these files, I won't be able to time travel back at to this instance, meaning different Parquet files got created at different instances. Imagine if I want to time travel back at to the instance of 1:11:06 p.m. IST. It is based on this file that I'll be able to come and state that the table contains only one row, one and hello world. But imagine if I did a vacuum command. What would happen is it would delete all the obsolete files based on the time parameter that I state. It would delete all the Parquet files, and in that case I won't be able to time travel back post the vacuum prior to the vacuum time travel. So under maintenance, if you can see, there is an option to run vacuum command. Now by default, the vacuum command can be executed via the portal of 7 days. I cannot reduce it less than 7 days. It must be minimum 7 days or more, meaning after 7 days I can, meaning those files that are older than 7 days, those would get removed as long as those are not active file, meaning under the log file, under the add path, this signifies that this is an active file. Remove meaning these are no longer active files. So vacuum command removes all the files that are older than the corresponding vacuum command. But unfortunately, via the portal, I'll just take 2 minutes, final 2 minutes. Unfortunately, via portal, one can only execute the vacuum command for 7 days or more. So there is an option wherein from the uh, notebook command, we can execute it. But if you see, this also failed. But it provides us that, are you sure you would like to vacuum the files with a such low retention period? If yes, then I have to disable a property wherein I need to disable this retention duration check property. So now I'll disable this. Post disabling this, now I can execute vacuum command retain for 0 hours. So now once I execute, now I can even execute vacuum commands for lower time period than 7 days. And what this basically does is this would go ahead and remove those files. This would take a couple of minutes to seconds to minutes, depending upon the number of files that are present here. So now this got executed. If I go ahead and now refresh my corresponding table, I'll see that all the other Parquet files that are obsolete have been removed. This is the benefit of vacuum command, which helps in optimization of your overall data. So this concludes the session. Are there any queries? Can you apply Z order to more than one column? If so, is the order of the columns important? Yes, you can apply Z order for more than one column. And yes, the order of the column is important in which, because it would first arrange it in that format. Let's consider ordering. Imagine that within the library, I have a shelf. I can first order it based on alphabetical, then I can order it based on the author, and then the version of that corresponding book. So that order of the data aspect does become critical. So one can consider Z order similar to indexing itself. So yes, you can apply Z order to more than one column, and the order of the column is important. So if you can see here, sorry, my fault. Within Z order is for fast filtering. If I'm majorly using sales date and store location, I can do this Z order by sales date and store location or store location sale date.